S1L24 is solving quadratic equations by taking square roots, and then towards the end of the lesson we also get into something called completing the square, which is just kind of like a specific case of solving by square roots, or kind of like a more advanced version. So 24.1 and 24.2 we're just going to kind of combine into the same section. So this one is truly just solving by taking square roots. So when you're solving by taking square roots, the goal is to isolate, which means like get it by itself. Isolate the portion that is being squared. So sometimes you'll see, like if we look at example 1, it's just the x that's being squared. My goal would be to get that by itself first and foremost. If we look at example 3, it's this entire parentheses that's being squared, so that would be what I wanted to isolate there. So just kind of keep that in mind. That's kind of our main goal to set up our problem solving. So example 1 through 4, solve each equation by taking square roots. Example 1 is x squared plus 4 equals 22. So like I said, the goal is to isolate the part that's being squared. So in this case, it is an x that's being squared. So right now I have to look, okay, what is being done to the x squared? A 4 is being added to it. So I need to undo that 4, that plus 4, by subtracting 4 from it. 4 minus 4 would be 0. Whatever I do to the left side of the equal sign, I need to do to the other side as well, just to keep that equation scale balanced. So I'm going to bring down the x squared, and then 4 minus 4, that's 0. Bring down the equal sign. 22 minus 4 is 16. And then now I have the part that's being squared isolated. So as soon as you kind of reach that goal, then we can go ahead and cancel out the exponent. So if we think about what is the opposite of squaring something, well, the opposite of squaring something would be taking the square root of something. So to cancel out that 2, the little exponent, we can still use inverse operations. It's just the inverse of squaring something is square rooting something. So I would square root both sides. And then when I square root the left side, it just cancels out the power and it just leaves me with x. And that's exactly what we want when we're solving, is we just want to get down to like x equals. And then when we're solving, so like I know that the square root of 16, that's asking like what number squared equals 16. So I know it's 4. However, when we're solving, we have to take into consideration like what are all the possible values of x here. So if I take 4 and I square it, that's 16. But if I take negative 4 and I square it, that's also 16. So that means that when we're solving and we take the square root of something, we have to include the positive and negative version of it. So you can write it as plus or minus 4, or you can write it as like kind of 2 separate pieces. So x equals 4 and x equals negative 4. It's totally up to you if you do it kind of in like one single part or 2. It has the same exact meaning. The solutions are 4 and negative 4. Okay, one thing I want to mention before we kind of move on to the next section, I didn't want to make a whole example out of this because I didn't know it was the best use of time. But if you ever get to a problem that has a negative number inside of the radical, so for example, and this is just kind of like a side example, I'll probably end up erasing it after. Maybe I'll actually throw it up here so it's out of the way. So let's say I have x squared equals like the square root of negative 25. So that's asking what number squared equals negative 25. And we just kind of talked about how like 4 squared is 16, negative 4 squared was still positive 16. So like how do we get a number squared equals negative 25? Because 5 squared is positive 25, negative 5 squared is negative, or not negative 25, negative 5 squared is negative 5 times negative 5, which a negative times a negative turns positive. So that's still positive 25. So that means that this isn't possible. So for right now, and probably like throughout the rest of the year, there will be kind of a time in your math career where you are able to like kind of solve it all the way through. But for now, we're going to say no solution or no real solution. You may see it written kind of both ways, between no solution and no real solution. Once you get to Algebra 2, we'll kind of introduce the concept of what's called like a complex number, which that happens when you take the square root of a negative number. It's called a complex number. Okay, so just kind of wanted to point that out. If you ever get to a problem that has you taking the square root of a negative, it's going to be no solution. And then for example 2, So same goal here, we're trying to isolate the portion that's being squared. So it's really important to know that if there are no parentheses around the 49 and the x, like the ones I just added, that means that the 2 only belongs to the x. Only the x is being squared here if you don't see a parentheses. The 49 is something separate that's just being multiplied by that x that's being squared. So now if we want to get x squared by itself, I have two things that are being done to it. There's that 49 that's being multiplied by it, and that 8 that's being subtracted from it. So usually it's easier to undo addition or subtraction first. So we'll undo that minus 8 by adding 8 to both sides. And then I'll bring down my 49 x squared. And then 8 minus 8, that cancels, or sorry, negative 8 plus 8, that cancels out. Bring down the equal sign. And then negative 6 plus 8. Whenever the signs are different, like there's one negative, one positive, you can subtract the two numbers. So like 8 minus 6 is 2, and then you take the sign from the bigger number. So 8 was the bigger number, and it was a plus, so positive 2. And then now still trying to get x squared by itself, that 49 is being multiplied by it. So to undo multiplying by 49, I'll divide by 49. And then you may notice like a lot of these steps are exactly the same as the same steps we've been doing all year. The only time where it's different is at the very end where we have to incorporate the square root. So we divide both sides by 49. 49 divided by 49 is 1, so that cancels out. And then I'm left with x squared equals, and then 2 over 49. We can't really like actually divide that. We'd get like kind of a crazy decimal, so we're just going to leave it like that, 2 over 49. And then if you could reduce it, you would want to like try, but in this case, like 2, we can only divide it by 2, and 49, we can't divide by 2. So if we like tried to divide both by 2, that would do us no good. So this is already reduced, so we'll leave it like that. And then now the x squared is by itself, so I'm ready to square root both sides to cancel out that little exponent. So square root the left side, square root the right side, and then the radical cancels out the like little 2 exponent. It leaves me with just x. And sometimes when you see a like fraction inside a radical, you're like, okay, there's too much happening right here. But it's not as bad as it seems. You just have to like kind of treat it like two different parts. So like that square root of 2 over 49 is the same as the square root of 2 over the square root of 49, and you just treat them both separately. So we would have x equals, if I were to take the square root of 2, that's like what number times itself, or what number squared equals 2? It doesn't exist. There's no number that you can multiply by itself, no like whole number that you can multiply by itself to get 2, because like 1 times 1 is 1 and 2 times 2 is 4. So that can't be simplified, but we still want to include the positive and negative version of that. So we put plus or minus the square root of 2, and then we keep our fraction. And then the square root of 49, we can simplify that, which square root of 49 is 7. Because if I take 7 and I raise it to the second power, that's 7 times 7, which is 49. So kind of working backwards, the square root of 49 would just be 7. And this section, like for sure, would be really helpful to have like a little chart or a table that has all the perfect squares on it. Okay, so x is equal to positive or negative square root of 2 over 7. Okay, so those first two examples, those were from like the 24.1 section, and then the next section is 24.2. You can see these problems look a little bit different because they have something in the parentheses that's being squared, but kind of, they'll look a little bit different, but the gist is the same. So example 3, x plus 12 squared equals 64. We talked about initially our goal was to get what is being squared isolated first and foremost. And in this case, it's the x plus 12 that's being squared. And isolated means there's nothing around it on its side of the equal sign. So there's like nothing in front over here, nothing in like behind it before the equal sign. So it's already isolated. So that first step is kind of done for us. So since it's already isolated, now we're ready to just go ahead and square root so that we can cancel out that power. Okay, so x plus 12 squared is equal to 64. I'm already ready to square root both sides, and then that will cancel out the exponent. And like I said, I'm able to do that because there's nothing outside of the parentheses that I need to cancel out first. So when I square root it, it's going to cancel out that 2, and then it's going to free up the x plus 12. And since the x plus 12 is not being squared anymore, I can go ahead and I could take off the parentheses. And then for the square root of 64, that's asking what number times itself is equal to 64? It's 8. So this would be an 8. But the same thing applies here where we have to do a positive and a negative 8, because 8 squared is 64, but so is negative 8 squared, because negative 8 squared would be a negative 8 times a negative 8, which a negative times a negative is a positive, and in this case it's positive 64. Okay, so not normally, but before we did this problem, once we got to the point where we had like a plus or minus number, the problem was done because x was already isolated. In this case, our problem's not done because we still have that 12 to get rid of. We couldn't do that though until we canceled out the exponent. So we've done that and we're ready to move on to the next step. So now though that we have like x plus 12 is equal to a positive 8 and x plus 12 is equal to a negative 8, we have to create two different equations. One where it equals positive 8 and one where it equals negative 8. So we'll create one equation, x plus 12 is equal to 8. And then the other equation is going to be x plus 12 equals negative 8. So one thing that's really important to notice is like this is an x plus 12. Those things don't change at all. It's just the 8, that one is a 8 and one is a negative 8. That's the only difference between the two equations. And then now we take each equation and we solve them separately. So like we have to cancel out the 12 that's being added to x to get x by itself. So we subtract the 12 over. Okay, so I bring down my x, and then 12 minus 12, that cancels out. And then I'm left with 8 minus 12, which is negative 4. And then on the second equation, it's the same exact step because I still have to cancel out that 12 that's being added. So I would subtract 12 from both sides. And then I would bring down my x, 12 minus 12 cancels out. And then negative 8 minus 12, when they're both negative numbers, or if it's like negative minus a negative, that's the same thing as like negative 8 plus negative 12 is the same thing as negative 8 minus 12. So you can just add the numbers together. 8 and 12 is 20, and then keep them negative. Because you have 8 negatives, then 12 more negatives, so you have 20 negatives. So final answer is, now that we have x completely isolated, our x equals negative 4 and x equals negative 20. Okay, example 4, r minus 7 squared is equal to 50. So looks really similar. It will be really similar. First up, check to see if what is being squared is isolated. The r minus 7 is being squared, and there's nothing around it on its side of the equal sign, so it's isolated. So when that's the case, we're ready to square root. So I square root both sides. And then square rooting the left side cancels out the exponent, and it frees up the r minus 7. So because it's kind of free now, I'm able to take off the parentheses. And then over here, I have the square root of 50. So 50 is not a perfect square. Like if you look at a list of perfect squares, it's not going to be on there. If you try to like think of a number times itself that equals 50, it wouldn't work because like 7 squared is 49, but then 8 squared is 64. So 50 would be somewhere in the middle of that. However, 50 has a perfect square factor, which means that this radical can be simplified. So there's two ways to simplify a radical. One is if you recognize what the perfect square factor is of 50, you can break it down that way. So what I mean by that is, so I know like the square root of 50, I know that 50 is 25 times 2. So I can break down this radical as 25 times 2, square root of 25 times square root of 2. And then I can take the square root of 25, which is 5, And then the 2, I can't take the square root of, so I would just leave it inside the radical. So that's method number 1. And that works if you can recognize what the factor is that you can take the square root of. If you can't, which is totally okay, there's a second method. So the second method is by making a factor tree. So 50. And you just have to think of any 2 numbers that you can multiply together to get 50 besides 50 and 1. So I think the one that pops into everybody's head is probably 5 times 10. And then you keep going until you get to prime numbers. So like for example, like 5, the only 2 factors of 5 would be 1 and 5. So that means that 5 is prime. So I stop at 5, and that's going to be one of my like leaves. So it's called a factor tree, so the ending, we just call them leaves. And then the 10 though, the 10 we can think of factors, it's 5 times 2. And then the 5 is only 5 and 1, so that can't go any further. The 2, the only factors are 2 and 1, so that can't go any further either. So these are all of my leaves, the 5, and the 2. So those are the only numbers that I look at, are all the prime numbers at the bottom. And then out of those numbers, I'm looking for a pair of the same numbers. A pair means 2. So I'm looking for, like in this case, I have 2 5s, and then I have a 2 that's left over. So any number that I have a pair of gets to come outside of the radical, and then anything that I don't have a pair of that's left over stays inside the radical. And again, I'm only looking at the prime numbers at the bottom, so 5 gets to come out because there was a pair, 2 was left over, so it has to stay inside. And then notice, like, these are the same answers. We got the same answer either way, so it's totally up to you on which method you choose. Okay, so that means that these like 5 times the square root of 2, they are equivalent to the square root of 50. They're the same thing, they've just been simplified. So we're going to replace the square root of 50 with those. So r minus 7 is equal to, and then because we're solving, anytime you take a square root when you're solving, you are going to include the positive and negative version of that radical. So positive or negative, 5 root 2, square root of 2. And then notice I put the plus or minus in the front. I did not put it in between the 2. It should be in front of that simplified radical because that 5 root 2 is just completely replacing the square root of 50. Okay, and then the last thing is we always want to get our variable completely by itself. So now I have to undo that 7 that's being subtracted. So to undo minus 7, I would add 7, and then I would add 7 over here. So bring down the r, and then negative 7 plus 7 cancels out. Bring down the equal sign. And then I'm not gonna lie, this part looks like pretty weird. We're not gonna add the 5 and the 7. We're not gonna add the 2 and the 7 because one has a radical and one doesn't. We can't actually like combine them. So what we do is we put the regular part of the number in front. We do 7. So the 7 first, and if it was like a minus 7, we do like a minus 7. So 7 first, and then plus or minus 5 times the square root of 2. Oops, I forgot the 5. Plus or minus 5 times the square root of 2. Okay, and then because a lot of the problems are multiple choice, it's really important to recognize like what answers are kind of written differently but mean the same thing. So the way that you would write this kind of in an extended version would be r equals 7. And then instead of plus or minus, we would just do a plus. 5 times the square root of 2, and then we'd have to write a second version, one with the minus. So r equals, same answer, 7, but instead of plus, it would be minus 5 times the square root of 2. So these together mean the same thing as this whole thing combined. So just important to know that they are the same exact answer. Okay, so 24.3 is called solving by completing the square, which just requires us to kind of go through a process before we're actually able to solve by square roots. So these problems are pretty step heavy, so I have the steps written right here. I would absolutely save this and like have these open as you're going through your own problems because they take a little while to get comfortable with, so it's nice to have the like written steps to refer back to. Okay, so example 1, x squared plus 6x minus 1 equals 0. So here's our equation. Step 1 says make sure your equation is in the form ax squared plus bx equals d. So what that means is that I just have the x squared and the x term on one side of equal sign, and my constant is on the other side. So I just want these two on this side, the x squared and the x, and then I want my kind of like constant, the one that doesn't have the variable, on the other side of the equal sign. I know it's a little bit different than normal, but for this process, we want that. So I'd have to figure out, okay, how do I get rid of that, like -1? How would I have to add 1? And then add 1 over here. And I'm adding 1 so that it cancels out on this side. And then if I cancel, or if I add 1 to the left side, I have to add 1 to the right side as well. So then I have x squared plus 6x, I bring that part down. And then -1 plus 1 cancels out, and I have 0 plus 1 on this side, which is 1. So this is step 1. So it's in that form now. And then step 2 says find b over 2 squared and add it to both sides of the equation. Okay, so b, like the in b over 2 squared, is referring to standard form, or like the fact that, you know, b is the coefficient of x. So b is like, a is always in front of x squared. B is always the coefficient of x when it's in standard form, or this form that's kind of like a variation of standard form. So we look for the number that's in front of x, which is 6. It kind of looks like a b, which is 6. So then I take that and I use this little formula, b over 2 squared. I put that 6 in there. That 6 got real ugly real fast, sorry. Okay, maybe that's better. Okay, so I put the 6 in for the b. So then it becomes 6. I think I'm psyching myself out. 6 over 2 squared. And then we simplify the inside the parentheses first. So 6 over 2 is 3. 6 over 2 means 6 divided by 2. And then after that, I have to square the 3, which is 9. So when it says, like, find this, it's looking for the simplified version of that. And then it says add it to both sides of the equation. So that means we'll add it right here, and then we'll add it right here. So that's what the next step is. So x squared plus 6x, and then plus 9. And then that's equal to 1 plus 9. So for step number 2, it's like this process and that process. Okay, and then now step 3 says factor your trinomial. So the trinomial is referring to like this 1, 2, 3 terms right there. So you can factor it, and it always factors like the same exact, not the same way, but with the same kind of pattern for a like completing the square problem. So it's kind of cool. I'm going to factor it the longer way first, and then I'm going to show you the shortcut. So just watch first, and then you'll write it like the second time through. So when we factor trinomials, they become like 2 binomials, 2 in parentheses. And when this is like a 1x squared, when the lead coefficient is 1, the x squared breaks down into x and x. And then I need numbers that multiply to 9, which is c, and then add up to b, which is 6. So multiplies to 9 and adds up to 6 is a positive 3 and a positive 3, because 3 times 3 is 9 and 3 plus 3 is 6. So you can factor it that way, and then you would end up like combining x plus 3 times x plus 3 into x plus 3 squared, because that's the thing about completing the square, is it always creates the two like same factors, so you'll be able to write it as x plus 3 squared. Okay, so the kind of like shortcut or like pattern type way is when we go through this process. So basically once we follow step 1 and step 2, we always create what's called a perfect square trinomial, which means that it'll always factor into a binomial squared. And then here's where the pattern comes in. So to figure out what goes inside of the parentheses, you look at the first term right here, and you take the square root of it. So the square root of x squared is x. And then you look at the middle term, which is a plus, and you just copy that. So since that's a plus, this will be a plus next. And then you take the square root of the third term. So the square root of 9 is 3, and that's the same answer that we got when we factored it the normal way. This is just kind of like a shortcut that we can take. So one more time, it's like the square root of the first term, so the square root of x squared is x. You take the sign from the middle, so if it's a plus, you do plus, if it's a minus, you do minus, and then you take the square root of the third term. So the square root of 9 is 3, and then we bring down the equal sign, and then now we need to go ahead and add these two together, so 1 plus 9 is 10. Okay, and then now this is kind of like the structure of what all these problems will end up looking like. And once we complete the square and factor, so this is step 3, then we can move on to step 4, and that says to square root both sides of the equation. So now we have kind of like a problem that looks essentially like example 3 and 4 from the previous section. So I'm going to erase some of this highlighting. But we have, and maybe move this down a little bit. No, it's okay. Okay, so we have x plus 3 squared equals 10. If we look back up, like that's kind of like the same structure as example 3 and 4 up above. It was like a number with x inside the parentheses equals another number on the other side. So now they're solved by square root problems, and we're ready to just square root both sides to cancel out that power. So I square root both sides. Square rooting the left side is just going to cancel out this exponent. So it's going to cancel out the exponent, and it's going to free up the x plus 3, and because it's freed up, I can take off the parentheses. And then the square root of 10, I'm just going to copy that down. So we always want to check to see if we can square root, if we can simplify. So one kind of like shortcut, if you're not sure, not really a shortcut, but one thing you can jump straight to if you're just entirely not sure is that factor tree that we talked about up above. So let's see, if I were to make like a little factor tree over here for 10, the only two factors besides 1 are 2 and 5. And then you can't factor any further because 2 and 5 are prime. So because I factored it completely, I look at my like leaves, 2 and 5, those aren't a pair of the same numbers. So I can't simplify the radical in any way because when I made the factor tree, I didn't end up with any pairs. So that means that we can't simplify it. Positive, or just the square root of 10 is simplified as is. So I'm just going to put the plus or minus in front of it as is. And then now I just have to get the x by itself. So I want to cancel out that 3 that's being added. So I have to subtract 3 from both sides. So then I do x equals the 3 minus 3, that cancels out. And then remember, we write the kind of like normal number without the radical first. So we'd write negative 3 first, and then plus or minus the square root of 10 second. Then our final answer would be x equals negative 3 plus or minus the square root of 10. And then this whole process, sorry, this is kind of like jumbled between step 3 and step 4, but this is step 4. From when we square rooted all the way down. Okay, so example 2. Same type of problem, so if you feel confident, you could pause the video and kind of read through the steps on your own, see how far you can get, if you get stuck anywhere, and then if you finish, check your final answer at the end. So example 2 is x squared minus 12x plus 11 equals 0. Step 1 is make sure your equation is, I don't know why I laughed at that, make sure your equation is in the form ax squared plus bx equals d, which means that I just want these two terms on the side, the one that has the x squared and the x, I want the constant on the other side. So notice that like in this one, they used like the constant equals d instead of c. It's all the same meaning, it's just a letter without a variable attached to it. So in order to get rid of that positive 11, I have to subtract 11 over. And then I bring down this whole thing. So that comes down. I have x squared minus 12x. And then 11 minus 11 cancels out. And then 0 minus 11 is negative 11. So I'm done with step 1. It's in the correct form. So ax squared plus bx equals d, x squared minus 12x equals 11. So, or negative 11, so we're all good there. And then for step 2, this is step 1. And then for step 2, it says find b over 2 squared and then add it to both sides of the equation. I'm going to do just the first part first. So remember, b is always the number in front of x. So we look at what is the number in front of just x to the first power, and that's negative 12. So b is negative 12, so I'm going to take that formula. So b over 2 squared, and then I'm going to put that negative 12 in for b. So negative 12 over 2, and then we'll square it. We divide inside first, so negative 12 divided by 2 is negative 6, and then we got to square that. And negative 6 squared means negative 6 times negative 6, which is a positive 36. So that positive 36 is what we're going to add to both sides of the equation. So we'll add it right here, and then right here after the negative 11. So step 2, the final part of it is going to look like x squared minus 12x, and then plus 36. And then equals negative 11, and then plus 36 here as well. So you always have to add it to both sides. And then now we can move on to step 3. So step 2 was this process, and then also this process. And then step 3 is to factor. So factor your trinomial. And remember, we can use kind of like a pattern. So anytime we go through step 1 and step 2, then our trinomial, in this case x squared minus 12x plus 36, is always going to factor into a binomial squared. So you can set up your parentheses and square it, and then we can use that pattern to figure out what fills in the rest. So it would be the square root of the first term. So the square root of x squared is just regular x, and then you take the sign from the middle term. So since that's a minus, we'll do a minus right here. And then last, we take the square root of the third term. So the square root of 36 is 6. So we do 6 right here. And then we end up with an x minus 6 inside the parentheses. And then we bring down our equal sign. And then add those two together, negative 11 plus 36 is the same thing as 36 minus 11, like we can just switch the order. So 36 minus 11 would be 25. And then we have a factor and our equation's so simplified. So I just want to go through the factoring one more time because like getting that pattern down is really helpful. So no matter what, like when we go through step 1 and step 2, we will be able to use this pattern. So it's always going to be a binomial squared, so that's why we can set up the parentheses squared first. And then you take the square root of the first term. So the square root of x squared is x. You take the sign from the next term, the middle term, and then you take the square root of the third term. So the square root of 36 is 6. And that's how we got each of those numbers. So that was step number 3, factor your trinomial. And then I'm just going to leave that up there as is and just kind of rewrite that step again, just so I can kind of keep that little pattern up there for you guys. So it's x minus 6 squared is equal to 25. And then we can move on to step 4. And step 4 says to square root both sides of the equation to solve for x. So kind of this, I know that there's a lot of steps to these, but the steps do stay really consistent. So if you can get those down, or if you can have them out next to you as you're completing the problems, you'll set yourself up for success a lot more. So step 4 is square root both sides. So I square root so that I can cancel out this power and start to free up the x. So square root the left side, that'll cancel out the exponent, and then I also have to square root the right side. So square root in the left side just cancels out the exponent, and it frees up the x minus 6, and then I don't need the parentheses anymore. So x minus 6 is equal to the square root of 25, which 25 is a perfect square. 25, or the square root of 25 is 5. So it's 5, and then we need to remember that anytime we're solving this entire section, we have to include the positive or negative version of that. So positive and negative 5. Basically, like when your goal is to get down to x equals, like that's what solving is you want to include that positive or negative version. So before we go through the rest of this problem, I want to go back up to an example that's just like this. So we had x minus 6 is equal to positive and negative 5 with no more radical because the radical fully simplified. So when that was the case, that was like example 3 up here. So we had, we took the square root of 20, 64, and we ended up with this. X plus 12 is equal to positive or negative 8. So when the radical fully simplified and we didn't have any more radical, we had to create two different equations because it could be fully simplified, versus if you have a radical, you can't like really add it, like in this case with like the 12 or the negative 12 and so on. Okay, so down here, we'll go ahead and because there's no more radical, we'll create the two separate equations. So they're both going to have an x minus 6 in it. That part will stay consistent. So x minus 6 is equal to, and then one will have a positive 5. So x minus 6 is equal to 5. And then one will have a negative 5. So the x minus 6 will stay consistent. X minus 6 is equal to negative 5. Okay, so this part, the first part of the equation, like the x minus 6 part, that stays completely consistent. And then the only thing that changes between the two equations is one is going to be a positive 5 and one is going to be a negative 5. And then now we solve both each separately for x. So if the goal is to try to get x by itself, there's a 6 that's being subtracted from it. So to undo subtracting 6, I would add 6 to both sides and then bring down the x. Negative 6 plus 6 cancels out, and then bring down the equal sign. 5 plus 6 is 11. And then for the other one, x minus 6 again. So I want to cancel out the 6 that's being subtracted. So add 6 to both sides. Negative 6 plus 6 cancels out. I bring down the x, bring down the equal sign, and then negative 5 plus 6. That's the same thing as 6 minus 5. You can go in like kind of reverse order. So 6 minus 5 is 1. So x equals 11. And x equals 1. So it's really important to know, okay, if I am so lucky that like my radical fully simplifies, I have to create the two equations. It's really important though that the two equations, the first part, like the x minus 6, that doesn't change. A lot of times people want to make the 6 a plus 6 in one of the equations, but that part will stay always the same. The only thing that changes is that 5 will go, like one will be positive, one will be negative. Okay, so I know I said a bunch of times, but like I said, I highly, highly, highly recommend that you have these steps out in front of you as you're completing these problems on your own. And then this whole process from here to here, that was step 4.